Hey guys, how's it going? So I'm gonna run this live in class, and so if you were in class with me um, on May 6th, you do not, or on May 5th, excuse me, you do not need to watch this video because it's going to be the things that we already did in class. But we're thinking a little bit about how molecules move and how that relates to temperature, and we're going to think about that using water. So I'm going to angle my camera down here, but I've got ice water. I've got boiling water that just came off my stove. Maybe you can see that steam coming up there. And I've got a couple different glasses that we're going to use to do a few different things. So the first thing that I want to do is I've got two cups here. And actually, I'm realizing I should switch their sides. So I've got cold on this side and hot on this side. And you can see because of the camera, the letters are flipped backwards. But in any event, I'm going to put boiling water into this guy and cold water into this guy. And what you can see is at the bottom, I've got salt, a bit of salt, and it's the same amount of salt in both of them. And so what I want to think about is, or just look at is there any difference between what happens to the salt when we add either cold or boiling water? So I'm going to add cold water here, and I'm going to add boiling water here. Now maybe you already have a prediction about what's going to happen, how it might be different. And then I'm going to give just one quick stir to each of these guys to help a little bit with the dissolving. Okay, and what we'll do is we'll take a look at that in a second and see what has happened. Okay, but we can also look at a few other things, and we can see the difference in the speed of molecule movement. So I'm just going to grab a glass. Two glasses. Let's see these two. For my kitchen, sorry, I should have set up. I will for class, but if you miss class, you're getting the practice video. Okay. So I've got two glasses here, and we'll do this short guy is going to be hot, and this tall guy is going to be cold. And so we'll say, and I'll even do your C correct direction for you this time, guys. There we go. That's right. And then hot. Hot and, hot and cold. Okay. So one of the first things we want to think about is this idea that if I've got hot and cold water, and I pour them, because it doesn't matter if an ice cube goes in. Ice cubes are fine. Oh gosh. Ice cubes on my computer. So I'll maybe add a little bit more here for my fridge, just so we can see the full effect. But there I've got water with ice in it. I know it's cold because it's got the ice in it, and I can just tell you guys it's feeling very cold. And then here, again, is my steaming hot water. You can see how hot it is, and the fact that it's fogging up the glass. But if we let them sit here for a minute, if there weren't ice cubes, if there weren't steam, or if we just focus on the water at the bottom half of these cups, like how different are they really? How is there anything different between this cold water and this, if I can hold it, hot water? Doesn't it look very much the same? And so what we want to think about is the speed of molecule movement and what we can see based on these temperature differences. So we'll use blue for cold and red for hot. And let's take a look here. Adding a drop of red food coloring to my hot water. What do you notice about how it's spreading out? And while that's happening, let's add a drop of food coloring to my cold water. Okay, maybe you can see a difference in how the food coloring is behaving in the cold water, which is the blue, versus the hot water, which is the red. What do you think that tells us about how the water molecules in the cold cup are behaving compared to those in the hot cup? Interesting stuff. Okay. going to move these off to the side. We'll maybe look at them one more time in just a second. Let's take a look at our salt. Hot. Cold. Okay. So if I look at the hot, I can see that there's really almost no salt left at the bottom there. There's a little bit. If I look at the cold, I can see in here, I can even turn this so you guys can see it a little bit better. I can see that there's a lot of salt left at the bottom of the cold. And so what that tells me is the hot water dissolved the salt faster than the cold water. And the question is, why is that? What is it about the speed that the molecules are moving at that means that the hot water would dissolve the salt faster than the cold water? Let's take a look again. Here. What do you notice? Which cup allowed the food coloring to dissolve most quickly? Now you can see in the red cup, in the hot cup, all the water is completely the same color red. It's all totally spread out. In the blue cup, that's not the case. In the blue cup, it's still spreading out, and even there's parts of the water that look totally clear. So what does that tell us? What does that tell us about how these molecules are moving? And then I just want to do one last thing before I wrap this up. Okay. Got some Jell-O. Letters are also backwards. That I am going to use. I'm going to make Jell-O later today. And what I realized is we can understand the reasons why certain directions are given if we understand the science behind them. So what I want you to do is take a look here at these directions. Oh, geez. Oh, it's all backwards. Oh, how silly of me. Well, I'm saying it's backwards, but maybe now that I'm recording this, I can probably flip it around. But backwards or not, take a look here. It says here you need 1 cup of boiling water and 1 cup of cold water. And it tells you add boiling water to the gelatin and mix for 2 minutes until the gelatin is completely dissolved. Why are they telling us to add hot boiling water? The next thing they're going to tell us to do on the directions is to pour cold water right on top of the boiling water once the gelatin is dissolved. What is the reason for the direction being first use boiling water, then dissolve the gelatin, and then add the cold water? Why is that? And how can it be explained in terms of the molecules that make up the water? Okay, so again, if you're watching this, it's probably because you missed class, or maybe you just really like listening to me explain sciencey things, in which case, cool, thanks. But if you did miss class, I really need you to try to be there next week. I'm going to be continuing to do experiments like this, produce videos, explain concepts, and I can't do any of it if you're not there. So let me not cut off the top of my head for just a second to say, miss you all. Hope you're doing well. You need to be coming to class. Okay. I'll see you soon.